From the heart of Glasgow, University of Strathclyde, their entry is certainly one of the neatest cars that I've seen here. It's got straightforward, solid engineering. It's got a space frame chassis, interesting aero, and a really straightforward electric powertrain. Let's have a deep dive into exactly how it works. Of many of the cars that we've seen here at Former Student today, one car really has stood out, and it's this car, and particularly the frontal area. So can you talk us through what you've got with these whiskers and with the canard going? What's it doing for the car and further airflow down?
Yeah, so for optimising the aerodynamic performance of the car, and we try and keep as much of a 50-50 balance of the car, so the aero balance basically right in the middle. And to do that, the most performance optimisation you have to do is on the rear wing, because everything upstream of that obviously affects the performance you can get out of the rear wing. So what these vertical whiskers are trying to do is outwash as much of the weight you get from the rear wing, or from the front wing, away from the rear wing, to try and optimise the performance you get out of the rear. And the canards here is to essentially create a downwash floor, a downward facing float, to try and get as much of the wake from these side tunnels, again, down and away from the rear wing. And we found that by trying to improve the rear wing performance rather than the kind of individual components, generates a kind of bigger performance overall for the car.
Okay, so you run an effectively slightly less rear wing because of all the work you've done up front?
Essentially, the front wing is a device to optimise the flow for everything else.
Yeah.
So we've also optimised for the side tunnels. We used to run kind of mid-plane end plates, but they would kind of create a concentrated point of shedding, and that would often end up in what we previously had was a side wing or now a side tunnel. Okay. So the front wing is essentially just an optimization device for the rest of the car. Also, with moving to a kind of more underfloor based design with a first ever run diffuser this year.
Okay.
We've also run two smaller elements instead of previously we'd run one big element.
Okay.
But the problem with the big element is you can quite easily stall the mid-plane. Which, if you're not running a floor, that doesn't matter, because if you've got low energy flow under the car, you're not really using it anyway. But with trying to use the tunnels and the diffuser, it's much better to try and keep as much energy of that flow, down the middle and underneath the car. So doing these split elements allows it to keep the more aggressive profile out here where we want the performance, but at the same time still allows our diffuser and tunnels to maximise their performance.
Excellent. Okay, so it's a really integrated design. Fantastic work. Next, I'd like to move on to the chassis and the suspension. So I want to talk about the suspension and the chassis. Now, the chassis is different because every other car we've seen so far and talked about today has been a carbon tub, but you have a space frame chassis. So take us through the design elements that you've got here and how the suspension works with it all.
Yeah, of course. So chassis-wise, we run a space frame. We've been around for 20 years and we're really familiar with the process. We're certainly thinking about carbon fibre monocoques, but there's certainly a lot of performance to come from a space frame. Certainly weight-wise, these are certainly still comparable to some of the carbon fibre monocoques you see. And just in terms of either manufacture and cost, it's certainly an excellent trade-off. And performance-wise, we get everything we want from suspension and all of the mounting of everything else. And it just makes it really easy for us. So that's a clear choice for us.
Okay, let's have a look at, I'm going to do this. I think I'd ask you to do it, but I'll be cheeky and take over. So we can see the tubular space frame here. Lots of triangulation, and then we come to the suspension package. So talk us through the rocker and the spring damper arrangement that you've got there.
Yeah, of course. So like some of the other teams that I'm sure you've seen today, we've moved to a decoupled system on both the front and the rear axle. So in this case, we've got a separate unit for the heave and the roll, and the same on the rear axle. So they're operating completely independently of one another. So if we make a spring change on one of those, we're not affecting the other motion of the car. And likewise with damping, it's completely separate in heave and in roll. And this is coming in part due to the aero package that Orange just talked about. So with this, we can better control the aerodynamics and better exploit the performance of the car. We've again used some steel welded construction, all made in-house. Looking at machining, it could be made out of aluminium, but the steel rockers that we've ended up with, they're actually really close in weight and do the exact same functionality. So again, we've got quite a nice cost trade-off and certainly manufacture ease, as welding and laser cut steel is sort of our specialty.
Okay, so is that welding done in-house, or is that something you've been able to...
That was all of us. We water jet the steel in-house, or we laser cut it, and then all of the welding across the car is done by us.
Wow, so it's quite impressive. This truly is University of Strathclyde chassis, isn't it?
We've sort of got the processes dialed. Our jigging processes are really, really good now. So making a chassis and making all of the suspension is just no bother now. So yeah, lots of steel, get it done.
So that's the chassis. Now let's move to the back of the car and see the electric powertrain and the electronics that run it. So we're now at the back of the car. Now, this is an electric Formula E car. Most people are quite familiar with all the components in a combustion engine car. Can you just tell us through what the key big units are in the back of the car here?
Yep, so there are 3 big units. So we have our high voltage battery pack, which stores all of our energy for all of our events. And then we have a motor controller, which takes that DC voltage of our battery pack and turns that into 3-phase electrical power for our third element of our powertrain, our electric motor, which transfers that electrical energy into kinetic energy, which makes us get off the start-finish line.
Okay. Now, we've seen some other cars here and they've got individual hub motors.
Yep.
You've got a single motor driving a differential, I presume?
Yep. So we have a MRAX 228HV. It is a permanent magnet synchronous motor. So it's a single motor which goes through a differential which drives both wheels. Kind of similar to an MX-5, for example.
Yeah.
We're driving the rear wheels with a single differential. So that limits us in terms of we can't do all of the cool things like torque vectoring, but it is by far the cheapest, simplest, most reliable system to implement in terms of a Formula Student EV.
Okay, so then you've got the hardware, so then you come into the electronics and the control strategies. So tell us a bit about what you've been able to do with the car here.
Yeah, of course. So between all our powertrain components, we communicate via a CAN bus. That's quite a standard in the automotive industry. So as El said, we have a motor controller, our high voltage battery, and they all communicate over CAN. And also they output various different bits of data, including temperatures, high voltages, currents and powers, which can all be logged via the same method.
Excellent. And in terms of work over this weekend, how has all of this setup work for you?
So we have quite a nice setup on our computer. Our kind of main interface is our ECU, which is kind of positioned at the front. All the CAN traffic is passed through there, and we have software in our laptop which allows us to easily calibrate different parameters within the car.
Okay, fantastic stuff. Very neat packaging as well. Thank you guys.
Thank you very much.